All right, hello once again. This is Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College AWD 1000 Web Development Technologies class, I've been creating a series of video presentations based off of the Mozilla Developer Network Learn Web Development series. All right, I'm in the JavaScript section and we're talking asynchronous JavaScript. And we've gotten to the concept of threads. And as mentioned there, and let me just preface this again it says, JavaScript, generally speaking, is single-threaded. All right. A thread is basically a single process that a program can cause to complete tasks. Each thread can only do a single task at once. So if things go the way they would normally go, all right, you do task A. When it gets done, you do task B. And when it gets done, you do task C, etc. And that's basically the way it works again in a synchronous type of setup, where each task runs sequentially and the task must complete before the next one is started. As mentioned earlier, many computers now have multiple cores, or multiple core processors, so they can do multiple things at once. Programming languages, as it says, that can support multiple threads can use these cores to complete tasks simultaneously. So while thread 1 is working on task A, and when it finishes that, it starts working on task B, if you've got multiple cores, you can have two threads running, where the first one, while it's running task A, the second one is running task C. Now, as mentioned here, JavaScript is traditionally single-threaded, even with multiple cores. You could only get it to run tasks on a single thread, known as the main thread. All right. So as they go from the example that we had above, where we looked at the thing drawing the million circles, we had to render those circles to the canvas and then display the alert. All right. After some time, as mentioned here, JavaScript gained some tools to help with things like this. Web workers, for example, allow you to send some of the JavaScript processing off to a separate thread known as a worker or a worker thread. So you can run multiple things of multiple pieces of JavaScript code simultaneously. So you'll generally use a worker thread to run an expensive process off the main thread so that the user interaction is not blocked. And that's what we want to make sure we don't do, is block the user from being able to do whatever it is they want to do. With this in mind, it says, have a look at the simple sync worker.html. So let's look at that one. We'll bring that one up and we'll just keep copying it into the same area that we've been in. Now, when we look at this, what do we have? Well, it looks like our interface is really simple. There's just a button here that says click me. All right. We are setting up an event listener for that button, and we're setting up a worker. And notice it says it's going to do a post message of go. All right. And then we've got this newly added paragraph. All right. And we're telling it to log. Let's run it and see what happens. So I'm saving. I'm going to jump back into here. I'm going to refresh. And I'm going to click the click me. It says failed to construct worker, cannot be accessed from null at that file. All right. Then let's jump back into here. This is a rewrite of our previous example that calculates the 10 million dates, but this time we're using a worker for the calculation. It says you can see the worker's code here in worker.js. Well, I probably don't have that file, so that would help, I guess. There it is. So let's come in here, open up a new window, and this will be worker.js. All right. Now, is this calling? Well, let's keep going through this. It says you can see the workers here. Now when you click the button, the browser is able to display the paragraph before the dates have finished calculating. Once the worker has finished calculating, it logs the first date to the console. The first operation no longer blocks the second. Well, I don't know if I fixed it or not. Still doesn't like it, so let's take a look and see what's different. So we'll actually run the working copy from their working copy. All right. So notice we immediately got this is a newly added paragraph. And after it's done with all those dates, well, we're not going to see it in there, but if we go to inspect, all right, and we go to the console, doesn't like something. There it is. In fact, let's go down to here and let's refresh. All right, we're down to here now. And let's click. You see it immediately shows, and then a little bit later, then our time shows. That's interesting. There we go. Web workers, as mentioned there, are pretty useful, but they do have their limitations. A major one is they're not able to access the document object model, or DOM. You can't get a worker to directly do anything to update the user interface. And really the rationale behind this is you're breaking away from the main thread where you should be doing things that are going to be manipulating the user interface. All right. We couldn't render our 1 million blue circles inside our worker. Basically, all it's doing is the number crunching for us. The second problem, as mentioned there, is that although code run in a worker is not blocking, it still basically is synchronous. This becomes a problem when a function relies on the results of multiple previous processes to run. It says consider the following thread diagrams. In this case, let's say task A is doing something like fetching an image from a server, and task B then does something to the image, like applying a filter to it. If you start the task A running and then immediately try to run B, you'll get an error because the image is not finished loading yet. All right, here's another one. In this case, let's say that task D makes use of the results of both task B and task C. If we can guarantee that these results will both be available at the same time, that might be okay, but the chances of doing that are remote. If task D tries to run when one of its inputs is not yet available, again, you'll get an error. So to fix these types of problems, browsers allow us to run certain operations asynchronously. As they mentioned, and we'll get into this in a later lesson, features like promises allow you to set an operation running, for example, fetching an image from the server, and then wait until the result has returned before running an operation that would rely on that. Since the operation is happening elsewhere, the main thread is not blocked while the async operation is being processed. It says we'll take a look in the next article and look at writing some asynchronous JavaScript code. This stuff is very, very important. All right, because you want to make sure that the user's experience is such, especially in a web application, that they're able to do whatever it is they want to do and they're not slowed down. All right, so modern software design, as it says, increasingly revolves around using asynchronous programming to allow programs to do more than one thing at a time. As more and more powerful and new APIs are developed, you'll find more cases where the only way to do things is asynchronously. It used to be hard to write asynchronous code, and it still takes some getting used to. I'm not going to say that it's easy, but it's gotten easier, as they mention here. In the rest of this module, the authors will explore why asynchronous code does matter and how to design code that avoids these types of blocking problems that we've been going over. All right, so we have now completed both the asynchronous JavaScript overview and the general asynchronous programming concepts. So now we're going into the introducing asynchronous JavaScript. I'll be back with that in a couple minutes.